Hello there. We have a big word problem in front of us, and we need to convert it into some equations. Math department's getting 3 one-topping pizzas, 2 two-topping pizzas, and 2 orders of breadsticks for $67.45. And the biology department's getting 2 one-topping pizzas, 3 two-topping pizzas, a single order of breadsticks, and a salad for $69.35. And then we get the history department and the economics department. So there I have my 4 equations, my linear system, 4 equations, 4 unknowns, and I'm going to convert this into a matrix equation. And the coefficient matrix is going to be a 4x4. Then we have to fill out all the entries there. An important part here is as I'm going across 3, 2, 2, there are no salads in the math department order. So that's actually going to get a 0 over there. Fill out the bio, fill out the history. Again, with history, you'll notice that there are no, it goes 1 toppings, 2 topping salads, there are no breadsticks, so that's going to get a 0. And then we're going to have our variables matrix over here, and it has to go in the order. 1 topping, 2 toppings, breadsticks, and this one was salads. And the other side is the resulting matrix, that's going to be the size of the bills. So just a reminder here of why this works. How is this 93.15 created? Well, that's row 3, column 1. So it's made by row 3, column 1. And as I go across the row down the column, I'm doing 5 times O plus 2 times T plus 0 times B plus 2 times S. And that gets me this equation right up here. 5O plus 2T plus 2S equals 93.15. So it's meaningful to convert this linear system here into a matrix equation. And I can solve matrix equations. Alright, this is getting kind of long. Copying the equation down here again. I'm going to multiply on the left-hand side by the inverse of this matrix here. I'm not going to find every single entry, I'm just going to write it down as an inverse. Okay, I need to shrink this a little bit, but we're applying the inverse of this on the left-hand side. It needs to be on the left-hand side, so I can do this 4x4 matrix times a 4x1. If I put it on the right-hand side, the dimensions are not going to work out. Now, what is this times this? And things are probably slip-sliding around here as I try to shrink and expand this. The product of these two is the multiplicative identity matrix. And the multiplicative identity matrix times our variable matrix is just the variable matrix all by itself. So now all I need to do is take the inverse, the multiplicative inverse of my coefficient matrix, found way back here, times that resultant matrix, that price matrix, the 4x1. Type this into my calculator. Make sure to remember to do the inverse. So matrix A inverse times matrix B, and I get my prices. So looking at this, I can tell that a 1 topping pizza is $11.95, a 2 topper is $12.95, breadsticks are $2.85, and a salad is $3.75. And I wrote that all out over here. As you get used to doing these kinds of problems, the setup's important, this equation up here, but then you don't need to show all of these steps. But the idea that an inverse, a multiplicative inverse matrix times normal matrix is the identity matrix, and that's all going to cancel out. So you could actually go from this step down to this step and then evaluate. So we had this big word problem, 4 equations, 4 unknowns, and we wound up doing it pretty slickly with matrices. Character and scholarship for life.